Hi, Assalamualaikum. Today I'm going to explain about chemical equilibrium. Before we go further, let's discuss the concept of irreversible reaction and reversible reaction. The chemical equation that we normally encountered looks more or less like this. It is called irreversible reaction. There is another type of chemical reaction exists and it is called reversible reaction. You can differentiate these two reactions by looking at the arrow used in the equation. The irreversible reaction use single head arrow that point to the product side, while reversible reaction use double head arrow that point to both reactant and product. This is what happened in irreversible reaction. Let's say we have A and B as reactant and C and O as product. In an irreversible reaction, A and B will react with each other to produce C and D. As long as A and B is available, it will continue to be converted to C and D. Once A and B is finished, the reaction will stop. However, in reversible reaction, the reaction can happen both ways. When A and B react, they will produce C and D. Once C and D is generated, they will have the possibility to react with each other and form back A and B. As long as A and B is available, it will continue to be converted to C and D. At the same time, C and D will also continue to react with each other to produce back A and B. This process will continue to happen in a cycle. As time goes by, it will reach a point where although the reaction is still ongoing, you will find that the amount of A, B, C, and D does not change. When one A and one B disappear to form C and D, other A and B will appear from the reaction of other C and D. The same happened to C and D. Any C and D that is used up to produce A and B will be replaced back by the reaction of other A and B. This state is known as dynamic equilibrium. It is a state where a reversible reaction, while still actively occurring, can maintain constant amount of both reactant and product. Because the amount of reactant and product remain the same, at macroscopic view, the reaction will appear as though it has not experienced any change, and one may thought the reaction has stopped. But at microscopic level, the actual reaction does not stop. At this point, the rate of formation of product is the same with the formation of reactant. Therefore, it is observed as though as having constant concentration.